All right, what's up, people of Twitch, people of YouTube? We are glad to have you here. Hey, everybody, my name is Lauren Schaefer. I've been on the stream a couple times, but I'm here without my fearless leader, Nick. So we'll see how this goes. But yeah, and I have here with me Ken. Ken, you want to introduce yourself?
Hi, I'm Ken. I think I did Twitch. I've been told I did Twitch a long time ago. I don't remember it, so clearly it wasn't that memorable for me. But I think it was a kind of a different format. Um, and yeah, I'm excited to do this today with Lauren.
I'm a little offended because I was on that stream with you, and so basically you're saying that hanging out with me was not very memorable.
Well,
You don't care. Okay, fine.
Something like that.
Okay. Now we
So
know.
I have a question for you about Twitch, Lauren.
Okay, we'll see.
Do you know why astronauts don't do Twitch?
Why, Ken?
Because in space, no one can hear you stream.
Oh my gosh. Okay. I apologize in advance for all of Ken's jokes because they're going to come and there's really very little we can do about it.
There's no telling when they're going to show up either. It just kind of happens.
Okay, so on that note, let's plug some stuff. That's what I like to do. So I'm on social. You can find me on TikTok and Twitter with the handle Lauren_Schaefer. I know. Ken, are you on TikTok yet?
I'm not on any social.
Well, lame, but maybe you're saving us from your dancing, so that's probably good. And I'm also on LinkedIn as Lauren Hayward Schaefer, and I'll drop some my link tree. Do you have anything you want to plug, Ken?
Not for me personally, no. Like I said, I have taken a step back. Oh, that's good. I've taken a step back from social media for a variety of reasons.
All right. Shiri says we need a meme from The Office to cleanse our palate. I think I agree. Or even better, a meme from Parks and Rec. I don't know if I have any today, though.
I'm guessing we're going to be having to endure some Parks and Rec references.
Yeah, they're coming. They're coming. Don't worry, Shiri. Parks and Rec is coming. Oh, yeah, I love seeing everybody say hi. I would love to hear where you're coming to us from. So I'm in Pennsylvania, which is on the east coast of the U.S. Ken, how about you?
I'm coming from my bunker in Oregon. Here, which is on the west coast of the U.S. It's the big patch of land between California and Washington for those that are geographically challenged.
Thank you. I am one of those people.
So shall we begin the show by getting started?
I guess. All right. So look, I did it. I changed the layout. Oh my goodness. Okay, so today we are going to be doing an intro to MongoDB for developers. So we have some slides. We got a demo. Let's see, what are we going to cover today? We're going to kick things off. I'm going to share some terms and concepts and the basics of how we model data in MongoDB. Then Ken's going to cover the MongoDB Data Platform. So MongoDB is a lot more than just a database. So we want to kind of give you a high-level overview of the whole platform. And then I'm going to do a demo for you so you can see some of that in action. And then Ken's going to wrap things up with tips and tricks so you're going to be super successful as you start using MongoDB.
Awesome.
Anything to add? All right.
It sounds like a good agenda.
Thank you. I was going to say I crafted it myself, but I don't know if that's true. Here we go.
Let's say it is.
Yes, we did it. We nailed it. All right, so we're going to talk about documents. And no, I'm not talking about Word documents. We're not talking about Clippy. We're talking about JSON documents. You would. You're the kind of person that would.
Well, I was alive back when Clippy was a thing, so. You know.
All right. So JSON documents, we're talking about JSON documents. JSON stands for JavaScript Object Notation.
Oh, I thought
So if you've
JSON was
used,
like the name of your husband or something.
it is it's very confusing around here. I don't know if do people say JSON? Like I say them differently, and I don't know if I've just made that up. I have Jason and JSON.
JSON.
Just me. JSON. Okay, so I'm not making it up. All right, so we're going to get through this at some point. We'll make it through. If you've used any of the C family of programming languages, such as C, C#, Go, Java, JavaScript, PHP, or Python, documents are probably going to feel pretty comfortable to you. Documents typically store information about one object, as well as any other information related to that object. So every document begins and ends with curly braces. And inside of those curly braces are field value pairs. Now, the great thing about documents is that they can be incredibly rich. So values can be a variety of types, including strings, numbers, arrays, dates, timestamps, or even objects. So you can have objects within a document. And you'll see what that looks like in just a moment. Now, when people talk about MongoDB, they'll often use the term non-relational. I don't know, Ken, have you heard people throwing that term around?
Oh, yes.
Yeah, they kind of trip.
It's like when I first started with MongoDB, I heard non-relational. I thought, oh, well, that's interesting. And then you get into it and it's like, well, that's not entirely accurate, but anyway.
Right. The name is a little confusing, right? Because MongoDB does support relationships. It's just a little different than how you would store relationships in a relational database. And in fact, a lot of people find that the way MongoDB stores relationships is easier to work with and more intuitive than a relational database. So you'll see in a minute here. So let's walk through an example of how you would model the same data in a relational or tabular database versus MongoDB. So this is for you, Sherry. Let's say we need to store information about a user named Leslie.
Oh, there's that Parks and Rec reference.
You knew it was coming. I can't do a presentation without him.
I know.
Yeah. You're so grumpy like Ron. You would be a great Ron.
Well, little Sebastian and I were buddies, so.
You know about little Sebastian? Did you do research for this talk?
Just for you, Lauren, just for you.
Oh my gosh. I was going to sing the song, but I'll refrain. But maybe some of the crew out here could sing a little Sebastian in for us. Okay, moving on. Let's talk about how to store Leslie's contact information. So in a relational database, we'll create a table named users. So we can create columns for each piece of contact information that we need to store. Things like first name, last name, cell phone number, and city. So to ensure we have a unique way to identify each row, we'll include an ID column. Now let's store that same information in a document. We can create a new document for Leslie where we'll add field value pairs for each piece of contact information we need to store. So as you can see, we have field value pairs for first name, last name, cell, and city. We'll use _ID to uniquely identify each document, and we'll store this document in a collection named users. So now that we've stored Leslie's contact information, let's store the coordinates of her current location. When using a relational database, we'll need to split the latitude and longitude between two columns. MongoDB supports arrays, so we can store the latitude and longitude together in a single field, and we'll call that field location. So now we're successfully storing Leslie's contact information and current location. Now let's store her hobbies. When using a relational database, we could choose to add more columns to the users table. However, since a single user could have many hobbies, meaning we need to represent a one-to-many relationship, we're more likely to create a separate table just for hobbies. Each row in the table will contain information about one hobby for one user. Now, when we need to retrieve Leslie's hobbies, we're going to join that users table and our new hobbies table together. Since MongoDB supports arrays, we can simply add a new field named hobbies to our existing document for Leslie. The array can contain as many or as few hobbies as we need. When we need to retrieve Leslie's hobbies, we don't need to do an expensive join to bring the data together. We can simply retrieve her document in the user's collection. All right, let's say we also need to store Leslie's job history. Just as we did with hobbies, we're likely to create a separate table just for job history information. Each row on the
table. Looks like a lot of tables.
That is a lot of tables. I know we're already to 3 tables and we're only a few slides in, right?
And we haven't even really done anything. I mean, like, this all just seems like something that should just be stored about Leslie.
Yeah.
But now we have 3 tables. Anyway, sorry. Oh, documents. Documents is a good answer for that.
Documents. All right, so it looks like Pratik is saying it's series like MongoDB University course. Ken, what is going on? Is that your dog?
Yeah, I have a couple dogs. One of them isn't happy at the moment.
Keep it together. Okay, so yes, there is an intro to MongoDB University course. Ken, you're the university guy now. Can you tell us about that course?
Yeah, I mean, they're probably talking about M001, which is our intro to MongoDB. And a lot of this information that we're going over today gets covered in there, but there's also a lot of information today that will be a good primer for some of our other courses as well.
And how much does MongoDB University cost?
It is, last time I checked, it was free, which is my price.
Yeah.
Right. It's great. It's free. It's yeah, go on mongodb.com/university and sign up, and there's all sorts of courses there.
Yeah, and they're really high quality. It's how we train all of our new technical people who come into the company. We send them through those same university courses. So they're top notch. All right. Okay, so we're talking about storing job history information, and Ken, you were saying this might be easier in a document. And
I mean, it might.
It might. We might be biased, but it might be. So far we've used arrays to store geolocation data in a list of strings, but arrays can contain values of any type, including objects. So let's create an object. Are you laughing at me, Ken? No, my
internet cut out on me because I'm here out in my bunker in Oregon, and internet isn't being nice today with the weather.
Lame. All right. So if you cut out, you're not laughing at me.
Well.
All right. Anyway, so to store Leslie's job history, right, we could create an array of objects. So inside of the array for job history, we have an object for when she was the deputy director, an object for when she was a city councilor, and an object for when she was director of the National Park Service's Midwest branch. Okay, so now that we've decided how we'll store information about our users in both tables and documents, let's store information about Ron. So Ron will have almost all the same information as Leslie. However, Ron does his best to stay off the grid, which it sounds like Ken is unintentionally keeping himself off the grid today.
I might be intentionally trying to keep myself off the grid.
All right, so Ron's not going to store his location in the system. So let's begin by examining how we would store Ron's information in the same tables that we used for Leslie's. When using a relational database, we are required to input a value for every cell in the table. So we're going to represent Ron's lack of location data with null. The problem with using null is that it's unclear whether the data does not exist or if the data is just unknown. So many people will discourage the use of null. In MongoDB, we have the option of representing Ron's lack of location data in 2 ways. So we can omit the location field from the document, or we can set location to null. Best practices suggest that we omit the location field just to save space, but you can choose if you want omitted fields and fields set to null to represent different things in your application. So you got a lot of flexibility there. So Ron has some hobbies and job history, so we'll add his information to those tables. And we can add that information to his document as well. So right now, the structure of Ron's document looks pretty similar to Leslie's. So let's say we're feeling pretty good about our data models and decide to launch our apps using them. Then we discover we need to store information about a new user named Lauren. Now, Lauren is a 4th grade student who Ron teaches about government. We need to store a lot of the same information about Lauren as we did with Leslie and Ron. So things like her first name, last name, city, and hobbies. However, Lauren's a kid. She doesn't have a cell phone, location data, or job history. We also discover that we need to store a new piece of information, her school. All right, so let's begin by storing Lauren's information in the tables as they already exist. All right, we got a question. What happens if you need a table with a lot of information related with the user? I'm not quite sure what this question, Ken, do you have an answer for this one?
I'm not entirely sure what they mean either. I mean, the document model does have some size limitations of how much you can put in each. If you're storing information about a user, you're going to be pretty okay with the size limitations that the document model and specifically BSON provides. But I'd like to know more information about what they're talking about there.
Cool. Okay. If you add more information, we can we'll grab that question. Okay, so we've got Lauren's information in the tables, the users table and the hobbies table. And let's talk about how to store her information in a document, right? We can just create a new document for Lauren and include the data we have for her in it. Now let's talk about how to store information about Lauren's school in our tables. So we've got 2 options. We can choose to add a column to the existing users table, or we can create a new table named schools. So let's say we choose to add a column named school to the users table. Depending on our access rights to the database, we may need to talk to the DBA and convince them to add the column. We might have to do a little begging to get our DBA to add the column. Maybe you have to do a little bribing. Maybe we bring our manager along to pressure the DBA into agreeing. If our DBA agrees, the database will likely need to be taken down. The school column will need to be added. Null values will be stored in every row in the users table where a user does not have a school, and the database will need to be brought back up. It's doable. It can just be a little painful. Now let's talk about how to store Lauren's school in MongoDB. We can simply add a new field named school to Lauren's document. We do not need to make any modifications to Leslie's document or Ron's document when we add the new school field to Lauren's document. Document databases have a flexible schema, so every document in a collection does not need to have the same fields. All right, so the question is, we got more information. Can Mongo handle an array of 1,000 or more hobbies without any performance issues? So massive arrays is actually a schema design anti-pattern, and I think 1,000 might be okay. It's when you start talking about getting these huge unbounded arrays that things get problematic. Ken, do you know what our recommended size limit is? Offhand, I can't think of what it is.
Yeah, I don't know either. And yeah, I think we can find that out. Yeah. And I would like to know the user that has 1,000 hobbies. I mean, I have a hard time trying to concentrate on a handful of hobbies, but that's another aside there. But yeah, that's a good point. I mean, arrays, I mean, you certainly don't want to have a huge array. I think part of it is going to be how things are indexed to handle performance. We'll get into indexing briefly in a while. Yeah.
And I think Nick is lurking behind our MongoDB channel. Nick, if you could grab a link to the massive arrays anti-pattern and drop that in, that might have some more information in it as well. Thank you, Nick. And Sherry's looking it up. So we got lots of people helping here. Cool. Okay. So back to this. So some people might be freaking out right now, right? Like if you come from a relational database background and you're looking at this going, okay, the documents are starting to have different structure. They've got different fields. Oh my gosh. You might be starting to panic at the idea of a flexible schema. And I know I started to panic a little when I was introduced to the idea. I don't know, Ken, did this freak you out a little?
A little bit. And then I think I know where you're going with this. So when I learned about it, the next thing that you're going to talk about, it caused me some relief. But I mean, I remember when you first joined, Lauren, and we had a lot of conversations about, what, how flexibility works and doesn't work.
Yeah, I like structure in all areas of my life, so this
No,
definitely
you don't say.
Freaked me out. I know. That's shocking for anyone who knows me. I like structure. So don't panic. You don't have to panic. This flexibility can be hugely valuable as your application's requirements evolve and change. And also, MongoDB provides schema validation, so you can lock down your schema as much or as little as you'd like when you're ready. And Ken, I think you wrote a blog post about this, I think a while ago, right?
Yeah, it's been a while. I think it was a 3-part, yeah, there we go. 3-part blog post on kind of what schema validation can do for you, sort of thing.
Yeah, so check that out if you want to learn more. So don't panic. And I'm realizing I should have asked this earlier. I'm curious, people in the chat, can you give us a yes or no if you have experience with relational databases? So that might help as we're looking at terms.
And how deep we have to go and whatnot with those terms.
Yeah. I don't know if we're on like a 10-second delay here, so we'll see. I have no idea if we're on a delay, actually. All right, I'm getting a few yeses here. Yeah, cool. Okay, so it looks like people have some experience with relational databases. So let's see. So what we're going to do now is map terms and concepts from relational databases to MongoDB. So on the left side of the screen, you're going to see tabular or relational database terms. And on the right side of the screen, you're going to see MongoDB terms. So first up, we saw this a bit in our earlier example. A row maps to a document. Or depending on how you've normalized your data, rows from multiple tables could map to a single document.
That seems easier.
It does seem easier. I agree. A column maps roughly to a field. Now, in a relational database, groups of rows are stored in tables. In MongoDB, groups of documents are stored in collections. So tables map to collections.
So
yes,
speaking of tables,
yeah.
Never mind. We'll
you have a bad joke? Go ahead.
No, it's okay.
All right.
It's that bad.
It's that bad. All right. I see someone's asking for the slides. Yes, they are published, and I will grab the link after I pass this over to Ken. I will grab it for you. The slide link is coming. All right, so the next few terms will probably feel pretty comfortable to those of you with relational database backgrounds. The terminology is basically the same between the two. So just like you store groups of tables in a relational database, you store groups of collections in a MongoDB database. Indexes are fairly similar between the two. Indexes help speed up your read queries. Views are pretty similar in both. There are a few different ways to handle joins in MongoDB. The general recommendation is that if you have related information that you would put in separate tables in a relational database, you should probably embed that information in a single document when working with MongoDB. The rule of thumb that I share all the time, I didn't make it up, but I love it, is that data that is accessed together should be stored together.
Can you say that again?
So, I would love to. Data that is accessed together should be stored together.
Awesome.
So if you're going to, I know, right? So if you'll be frequently accessing information together that you would have put in separate tables, you should likely just embed it in a document. Now, there are a few other options for joins as well. MongoDB supports references between the documents, similar to how you would use a foreign key. MongoDB also has an operation called $lookup that will support a left outer join. I'm not going to go any deeper on those today, but I just want you to know that it is possible to join data from more than one collection in MongoDB if you really need to. Great question from CryptoDive. Can someone recommend some good documentation which is available offline?
Yeah, so there's tutorials, developer.mongodb.com. Our documentation site pretty consistently ranks really high in terms of corporate and product documentation. So you can find that online as well. In terms of offline, I don't, if you're looking for hardbound paper sort of things, there's a lot of various really good resources out there, in printed material that I don't really want to pitch and promote for a variety of reasons.
Okay. I will not ask any more questions then, although I'm very intrigued.
I just find it a little weird to promote books and stuff with, I don't know. I mean, there's a gentleman on my team that wrote a book on MongoDB. So I would look up Owen's book, but, give him some royalties.
Yeah. Do you know the name of that one or how to spell his name?
EOIN. And the last name is Brazil, Brazil.
Good job getting that right. That was a test. You passed.
Yeah, you can't spell your colleague's name. That's a problem.
All right. Question from Nick. Is it slower to populate or fill in references across collections than within the same collection? I'm not sure what they're asking. Do you know?
No, I don't. So Nick, if you can provide a little bit more clarity on that. Yeah. So, and if you want to look for Owen's book, it was also Shannon Bradshaw was a co-author on that. It's MongoDB, the Definitive Guide by O'Reilly. And Christina Chodorow is, yeah, there you go, Sherry.
Thank you, Sherry.
Yeah. So
All
back
right.
to next question. Hey, can our magic behind the scenes, Nick, pop that question back up so that I can refresh my memory on that? Is it slower to populate fill-in references across collections than within the same collection? I mean, if you're doing it across collections and it's not embedded in the same document, then you're winding up having to do some sort of join operation, right? Of finding document A as it refers to document B. And that's just inherently going to be slower than pulling up the information. And what's your rule of thumb, Lauren?
My rule of thumb, data that is accessed together should be stored together.
Yeah. So yes, it will affect performance if you're joining things versus embedding. Like embedding is going to be faster because you're not having to go across the network. And, I mean, think of something if you're reading a book and all the information is on the same page versus having to go back to the index or wherever and find it in a different chapter and then pull the two bits of pieces of information together. It's going to be faster if it's all in the same document.
Cool. All right. Last term, transactions. So transactions group database operations together, so they either all succeed or none succeed. Now, if you've done some research online and you Googled, when should I use a relational database versus a NoSQL database, you probably saw something about NoSQL databases not supporting transactions as a major drawback. And if you care about data integrity, and really, who doesn't, right? That's a pretty scary sounding drawback. Now, some NoSQL databases support ACID transactions, while others do not. So in relational databases, we call these multi-record ACID transactions. And MongoDB does support transactions. We call them multi-document ACID transactions. However, when you model your data from MongoDB, you'll find that most of the time, you don't actually need to use a transaction. All right, so to wrap up this section, I created this very busy looking term mapping summary for you.
I bet design loved that, didn't they?
They did. They loved going through my slides. So just try to internalize those first three, right? A row maps to a document, a column maps to a field, and a table maps to a collection. All right, and with that, I'm passing it over to you, Ken.
Awesome. Thank you, Lauren. Bear with me, folks, if my internet makes my slides a little jumpy. Anyway, so far we've introduced NoSQL and document databases and focused on MongoDB, which comparing, and kind of comparing them back to traditional relational databases. By the way, Lauren, did you hear about the 3 relational database DBAs that walked into a NoSQL bar?
I've not.
Well, they left after 5 minutes because they couldn't find a table.
Okay.
All right. Anyway,
okay. I'm sorry, everyone.
We've covered a range of aspects relating to writing and designing applications for MongoDB. But MongoDB really isn't just a database product. From several years ago, we've kind of moved from just being thought of as a database to kind of a complete data ecosystem. And we like to refer to this as a data platform, which really consists of a number of different tools. And we'll cover some of these tools in relationship to our ecosystem. But there's 3 aspects of a data platform that we'll look at, and they're related to storing the data, accessing the data, and processing the data. Tom, that's great. We like it too. Thank you for being a fan. So storing data, accessing data, processing the data, and these will help to show the range and usefulness of the tooling ecosystem within, sorry about the dad jokes, but I'm a dad, so there you go. So we're gonna cover the different tooling ecosystem in MongoDB, and tools like Atlas, Compass, Charts, Data Lake, and a few others that are all kind of part of the MongoDB data platform. So let me see here.
Am I on the right slide, Ken?
Next slide.
Okay.
All right, there we go. Yay. So in order to store the data, which is something that databases should be able to do, we need to have a database installation. So within MongoDB, we kind of have 2 different options for you. You can either run it self-managed, which has some flexibility, but it also comes with a lot of headaches in terms of overhead and maintenance that you have to handle yourself or your team does. Or you can run it in MongoDB's cloud service, MongoDB Atlas. So self-managed, again, means that you can have the data on your own laptop as part of your development environment. You can host it on your own server, mainframe, or yourself in a public cloud provider. And if you're going to do that, we have a tool called Ops Manager, which is what we recommend to manage, monitor, and back up those types of environments. MongoDB Atlas, which is our database as a service, is where MongoDB ourselves will manage and automate your deployment in one or many public cloud providers. So right now, our cloud providers that we currently offer are Amazon's AWS, Microsoft's Azure, or GCP, Google's cloud platform. So MongoDB and its team will manage and maintain your databases. Additionally, all of the same tooling and features available in Ops Manager are also available inside Atlas. All right, so let's look at the first aspect of how MongoDB is a data platform, specifically how the data is stored. So at the core, MongoDB Atlas runs the latest version of MongoDB. This ensures that it can avail, to all the new features and upgrades of versions that are handled automatically by Atlas itself. MongoDB Atlas can be hosted, as I said, on any of the big three cloud providers, AWS, Azure, or GCP. And we've also recently, and I really think this is a cool feature, like to hear what everybody else thinks, and maybe Lauren has some insights on this. But we recently announced support for multi-cloud support, so you can put the same application data across multiple clouds to allow you for taking advantage of the services the different cloud providers offer, and also increases your resiliency, right? But so you could have your data stored on, and I'm just throwing this out there, on AWS and GCP or Google, right? So you could take advantage of some of the tooling that AWS offers and simultaneously take advantage of the tooling that GCP offers without having to move your data.
And if one of the cloud providers goes down, you're still covered, right? Your app can stay up.
Yep, you can still, and it also, so not only do you have that resiliency, but it also doesn't lock you into just one cloud provider, right? Like, who knows what cloud providers are going to do, but if one cloud provider all of a sudden tripled their rates, you could very easily still have it on another cloud provider. Anyway.
And what Victor is asking, is there a trial or free tier on Atlas?
There is a free forever tier on Atlas. It's great for development environments, kind of sandboxing your projects. It's a shared tier, but you still get a lot of great features and all of the wonderful flexibility that Atlas provides. Anything you want to throw in there, Lauren, on the free tier? Nope.
Nailed it. Oh, I lost Ken. Is it just me, or did everyone lose Ken? I'm talking.
So Atlas isn't just a database alone. It's which utilizes. Oh, that's a problem. Maybe I froze.
You're back. You froze for about a minute.
I'm back.
You're back. Can you start again?
Sure. So did I leave off where Atlas wasn't just a database alone? It's kind of a key element. It's really a key element of the platform itself. And it provides support and runs other toolings, things like Atlas Search, for example, which utilizes Apache's Lucene to provide really fine-grained full text search queries using our query language, the MongoDB query language. We call it MQL, which is what it's, it's the acronym for it. And Atlas also links with Atlas Data Lake, which provides storage on Amazon's S3 and can be configured with auto archiving to move older data or data which is no longer relevant to your operational workload to that cheaper storage. It can also still be queried using MQL, and we'll take a look at Atlas Data Lake here in just a little bit more. Yeah, I would love to get better internet, but I live way out in the country, and we don't have that as an option.
Boo.
Yeah, well, there's advantages and disadvantages to wherever you live, I guess. So if we look at the Atlas Data Lake here, and data lakes are really increasingly becoming more common. And it's essentially a centralized storage point for your data, whether it's structured or unstructured. In the case of Atlas Data Lake, the centralized storage that we're currently using is Amazon Web Services, AWS's Simple Storage Service, or S3. And our data lake supports a wide variety of file formats, including JSON or JSON, BSON, CSV, TSV, Avro, ORC, and Parquet. And these can be queried using the same query language used with any MongoDB database, MQL. The queries can be performed using the Mongo shell, which is a command line interface, MongoDB Compass, which is one of our products, and we'll talk about that here in a little bit, or any MongoDB driver, so just natively inside your application. And these queries don't trigger any data movement or transformation of the data. So the queries are performed actually against the data that are sitting on Amazon's S3. So one really useful feature in terms of a data platform, in my opinion, is the ability to configure rules. In Atlas, the rules can be configured to trigger the automatic tiering or archiving of data from an Atlas cluster to the Atlas data lake. So this can
is
move,
so cool.
Yeah,
I'm going to demo this in a minute. This is amazing.
Yeah. This moves the data targeted by the rules. So, for example, typically older or infrequently accessed data, you can move it from an Atlas cluster to a read-only data lake on S3 without requiring any user action. So, barring the initial rules set up, of course. It also allows a unified view of both your Atlas and data lake data by querying the data lake with MQL. So the second aspect of a data platform is accessing the data. One aspect of data access is workload isolation. And I really find this pretty cool too. I mean, I really find all of our products cool, and our products and features are cool.
Sure.
But workload isolation I really like as well. So being able to run operational workloads along with analytical workloads on the same platform is a big advantage, as it means you don't need to provision a separate database or set of resources to service your analytical queries. This is done by designated, and Victor, I'll answer your question here in just a second because we'll get into MQL here. That's kind of the next topic here. Where was I? So you can designate a specific set of nodes to be read-only and which service your analytical queries, which I find really powerful, right? You don't have to have a complete different set of nodes for analytics. It's the same data that you're using in your workload, so real-time analytics becomes much more possible. MongoDB Atlas can provide one set of those nodes which are focused on servicing your main traffic for your operational applications. These nodes continue to replicate any changes or updates to a second set of nodes, and the second set of nodes then could potentially serve your analytical queries. Then your application can target which of those nodes should service the request depending on what the purpose of the request is. It's really a powerful feature. Oh, here's another busy slide that I'm sure design really enjoyed. MongoDB as a data platform has, another useful feature, but that's not as well known, really. So change streams provide a mechanism for applications to subscribe to changes, whether on a single collection, a database, or an entire deployment. These are streaming as they happen to the application, so it can react to them immediately. Have you used change streams very much, Lauren?
Yes, I just built a demo app with them last week, and it's so fun to watch your changes happen live in your app as they're happening in your database. It's so cool.
Yeah. So real-time data changes occurring in a range of applications such as business applications, user data, sensor data, clickstream data, data changes, right? Change streams, and specifically the change stream API, allow for applications to access and consume these real-time event notifications. Change streams aren't just limited to your application, though. They underpin a number of other tools in the wider MongoDB ecosystem. Change streams use the aggregation framework, so it allows for additional filtering or transformations to be applied to the changes as they are sent out. Business apps, such as MongoDB Charts, can use change streams as a data source, allowing additional use with Charts embedded SDK to include the functionality of both charts and change streams directly in your application. And we'll talk about charts here in a second. Atlas triggers use change streams. MongoDB's Kafka, easy for me to say, connector also uses change streams. Really, change streams underpin a lot of our data platform.
And I'm going to do a quick plug for the quick start tutorials on developer.mongodb.com. So we've got quick start tutorials for a lot of our language drivers. So like, for example, I wrote the Node driver ones. I think, Ken, you wrote the C++ ones?
I hope it wasn't C++.
What did you write?
I think it was the C# or
C#,
.NET.
okay.
Yeah.
Okay. So, and I just updated my Node.js tutorials this week, so they are hot off the press. And we cover change streams as one of the articles in those series. So if you want to try out change streams, that's a great place to start.
Yeah. Speaking of C, Lauren, speaking of C, all right, never mind.
No, go ahead. The people want your jokes. Come on.
People want, do you realize that without the C programming language that we'd all be stuck doing OBOL and BASIC, right?
Oh, gosh. Okay, maybe we should ask the people, do they like the jokes or not? Should we stop? Should we cut Ken off? All right.
I mean, I'm good either way. Okay, so MQL. We had a question about MQL and kind of the learning curve. It is different than SQL because it explores a different data, underlying data structure. The learning curve, I didn't find it to be that huge of a lift to learn MQL. And in fact, I found it much more intuitive just in the way that things are laid out and structured. I spent, in previous jobs, I've spent a lot of time doing SQL and reading, page after page of SQL queries got tedious and trying to, thanks, Jack. There's one vote for Ken. Thanks, Jack. There and Nick. Hey, woohoo. So, oh, Shane. Thanks, Shane.
No, I won't laugh at his jokes. I won't laugh at them.
Anyway, I found MQL to be pretty easy to learn. Mostly because
the MongoDB.
Go ahead.
I should say the MongoDB University course that walks you through that, the intro course, makes it really easy to pick up.
Yeah. And I started using MongoDB before they had that intro course, and it still wasn't that bad at all. So it's, MQL, it's the query language tailored specifically for MongoDB and our document model. It allows for high performance queries in a syntax that's very readable in most of our opinions and really easy to use. So we can look here at a real quick example. So if we go to the next slide, yay.
I'm paying attention. I'm paying attention. I'm here.
It's all right. It's all right. So if we look at this syntax, here we're specifying a database, and we're calling it DB, and a collection inside that database. Remember, database in the relational world, the term database relates to a database. A collection is kind of mapped to a table. So we're looking at a collection inside our database called inventory, and we're issuing a find command. There we go. Product placement. You should start getting some revenue from Mountain Dew.
I keep trying. I would just take free Mountain Dew from them. I feel like we should have a MongoDB Mountain Dew channel. It's going to be amazing.
There you go. So again, looking at this syntax, right, we're issuing a find command. So this to me is pretty readable, right? Going back to the difference between SQL and MQL, we're looking for a document inside the inventory collection, and we're passing in an empty query filter. So this really kind of corresponds to a select star from inventory statement in the SQL language. So if we wanted to find, for example, an inventory item with the name of typewriter, we could pass that into the query parameter. And that's all that we do somehow all right, yeah, that works perfect. All right. So MQL provides that rich query language, providing support for full CRUD operations. So create, read, update, and
Oh no, did we lose Ken again? I can finish his sentence for once. He was about to say create, read, update, and delete.
delete.
But that's all I know.
Create, read. Oh, I got frozen.
Yes, we heard you say create, read, update. Ken, are you back?
Yeah, and then the last one is delete.
Delete.
I think I'm back. Delete. Yes, those are the 4, right?
That's it.
Awesome. You can also do text search in MQL, geospatial queries, and a lot more. All righty. Next up is processing the data. The first tool within the data platform to processing data is MongoDB Compass, which is our visual data explorer. It runs as an application on your desktop, laptop, and can connect to a local or a remote MongoDB deployment. And it'll let you view the data with many different visualizations. I remember when Compass first came out and was just blown away by the flexibility and the ability to visualize your data and your collections and do the things that Compass allows you to do. So it allows you to do the CRUD operations inside the application. Again, CRUD is create, read, update, and delete. On individual documents in your collections, it has a visual query builder to help you construct complex queries for MongoDB query language or for the MongoDB aggregation framework. And it also provides a really cool schema analyzer so you can identify schemas for a given data set or data sets. Do you use Compass very much, Lauren?
Yes. I actually really like Atlas. I use Atlas most of the time, just to be upfront. Atlas does most of what I need to do.
Yeah, Atlas, a lot of the features of Compass have been rolled up into Atlas, but I still really like Compass. So the second tool in the MongoDB data platform that can help with processing data is MongoDB Charts, which is on the next slide. And
I do use Charts a lot.
Charts is awesome.
Yeah.
It's an analytical tool designed specifically for the document model, right? As you might imagine, having things like embedded documents and arrays are not as easy to visualize as some other data structure forms. But Charts has figured all that out. And it provides additional flexibility when compared to using analytical tools designed for relational models. Oh, and there goes my dogs. It's a dog-eat-dog world out there, I guess.
Oh.
Sorry. Charts provides a variety of chart types, such as a lot of the more common charts like bar, column, and line. But it also provides some really cool complex visualizations, such as geospatial heat maps and scatter plots. And you can use those chart types along with the location data. For example, the stuff that Lauren showed with, was it Leslie or Ron? Ron didn't have location data because he doesn't want it known. Or maybe, here's my theory, maybe Ron actually lives in Eagleton. He just doesn't want anybody to know about it.
I don't think that's true. I don't think he likes Eagleton either. I reject that theory.
Okay. All right. Charts is hosted within MongoDB Atlas, and you can use charts developed by the Charts tool and embed them. And I really like this feature too. You can embed the charts that you make within Atlas into external documents or web pages or mobile apps. You can share the charts via links. And there's a lot more to charts. And if you're interested in the fastest and easiest way to visualize your MongoDB data, I'd encourage you to take a look at that. And I think in your demo, there's some real basic chart stuff, isn't there?
Yes, we're going to see a dashboard.
Awesome. Is MongoDB Charts free? It is part of Atlas, so it comes with Atlas, and it all will depend on your tier of your data storage.
But
But
you
like,
can
yeah, on the free tier, you absolutely can use it for free. The third and final tool we'll cover for processing data is the Business Intelligence Connector, or BI Connector for short. And this tool allows you to visualize your data within MongoDB with some of the, I mean, Charts is great, but some of the data visualization tools that are specific for data analytics marketplaces such as Tableau and ClickSense and whatnot. You can use the BI connector to allow those tools to access your MongoDB data. It essentially allows those tools to kind of get a MQL to SQL conversion going on, and so the BI connector is kind of that translation layer for the SQL to queries against your MongoDB collections. So wrapping up the concept of MongoDB as a data platform, I really want you to kind of recall the three aspects of a data platform and the options MongoDB currently provides. The first is storing the data, be that self-managed on-prem to a fully managed cloud model with MongoDB Atlas. You can store the data where you'd like across multiple cloud platforms. You can even start to store now your data in AWS S3 bucket with Atlas Data Lake, which can save a lot of money on your data storage. So next up is accessing the data. I mean, what good is storing it if you can't access it? I don't know what good that would be. Like if you could store all your data in MongoDB but never access it, then we probably wouldn't be here. So features such as workload isolation, change streams, MQL allow for different aspects of your data access. And then finally, for processing the data, we have things like Charts, Compass, the BI tool, and whatnot. I feel a demo coming on.
You're right. It's demo time.
Woohoo!
Are you so excited? That's Ken's fake excited voice, but this is going to be interesting because I feel like hearing about it and like seeing the slides, you kind of get the idea, but then once you see it in action, you're like, oh, I get how I can use that. So
let's see it.
Let's see it. Today we're going to talk about WildAid and OFish. So
nothing fishy about that.
Oh, people need to stop encouraging you. So WildAid is an organization that works to protect vulnerable marine environments. So MongoDB built a mobile app for WildAid last year. So the app is called OFish. There we go, this way. And OFish stands for Officer Fisheries Information Sharing Hub. It's quite a name. So the goal of the OFish app is to make it easy for officers who are boarding fishing vessels to easily store the information they gather while on the vessel. So when the officers board the vessels, they're checking for any fishing violations. Now, before the app existed, officers were like recording the information with pen and paper, and then they, when they were on the boat, and then they were transferring the information to a digital copy when they got back on land. So now
I'm guessing that on occasion, like pen and paper, when you're on the ocean, paper might get wet and you might have some issues with your data.
Yeah, surely they had like page protectors or something. Surely.
Let's say yes. Let's say yes.
Okay. But yeah, right? Like that's a pain because you're doing it twice. So now they can get on their mobile app, regardless of whether or not there's internet, and input the data. And you're only having to do it once, which that's what I like to do. Who wants to do the same thing twice? So let's take a look at the web app for OFish. So I've already logged in, And let's say that I want to search for a crew member named Van. So I can search here. And okay, well, I meant to type Van, but I typed can. That's okay. It looks like we've got some good fuzzy matching working here. So I'm going to choose to see all results for can. MongoDB knew what I meant. All is well. I know I want to find the crew member named Van, so I'm going to click See All here. I don't know, Ken, can you see it? So anything that matched is actually in bold here. Is it a little hard to see?
Yeah, I can see it. There's Van
Okay,
and
so
Fan and Van.
Van and even cap down here. So that doesn't rhyme, but it still matches, 2 of the 3 letters. So we've got some options here. Let's say I want to filter. I know that Van does not have any violations. So I'm going to click green for him. And there we go. We found Van. So I can click on his record and we can see all of Van's information, right? Pretty simple. So the nice thing here is that the app is not using any sort of third-party search technology. This is all powered completely by MongoDB. So let me jump over to Atlas so you can see this in action. So this is Atlas. This is what Ken was talking about, right? This is our fully managed database as a service. So you can see we have a database named WildAid. It's got a variety of collections here, and I'm in the boarding reports collection. Atlas has a really nice way that you can browse documents. So here's a document, I can expand it, and I can see lots of information is being stored in this particular document. Okay, but we were talking about full text search. So I'm going to go head on over to the search tab. And let's see here. Making sure I don't forget anything. So this particular search index is using all the defaults. So it's dynamic. It's indexing every field, which is fine. This collection doesn't have a whole lot of data, so that's fine. But if we had a lot of data with a lot of fields, a lot of data in it, we'd probably want to limit which fields were being included in this index. But this is going to work fine. So I was able to create this index in just a few clicks. And now I have full text search in my app, right? I'm not having to do any sort of third-party plugin. It's all built in, ready to go, nice and easy. Ken, are you wowed?
I am.
Ooh.
Ooh.
I know. Love it. Thank you, John Barry. Great information. All right, so let's talk about dashboards and charts. So
This looks like
dashboard.
charts.
This looks like charts. It's because it is. So this is a dashboard for WildAid, and we can see a variety of charts in here, right? We've got some nice quick summary numerical charts. We've got a donut chart. I'm going to scroll down a bit.
It's still breakfast here.
Map.
Donuts make me hungry.
Oh, gosh. Okay. Here are the dots on the map. And so you can scroll in, and it's very interactive, which is super handy.
So, question for you here, Lauren. How complicated is it? I mean, that geo map there looks pretty complicated, right? Like, I mean, you have country names and capital names, and that looks like that would be a real time intensive thing to create.
Yeah, one of my previous jobs was to create a dashboard like this using D3, and this dashboard would have taken a lot of time. Like, we had a team of people building a dashboard like this, and this was all created point and click. Like, this is a built-in chart type, which is so nice. I'm a programmer, and I still don't really like if I can point and click, I'm still going to do that, right? Like, why overcomplicate things? It's built in, it's easy.
Yeah. So to that point, with those geolocation maps, if you structure your location data like Leslie had in her sample document from earlier in the Twitch stream here, MongoDB Charts just knows what to do with that. It's pretty slick, in my opinion.
I agree. So let me jump over into the charts interface. So I'm still over here in Atlas, right? We've got up at the top the Atlas section, the Realm section, which we haven't even talked about, but Realm is amazing as well. Did you talk about Realm and I'm forgetting?
I have not.
Okay, Realm is amazing. We're not going to get into it today, but definitely check it out. and then I'm here in the charts section, and I've opened up my dashboard. And so here you can see the different charts that were displayed on that dashboard in my app. So if I want to embed a chart, I can just right click on it, or hamburger menu, click on it and choose embed chart. And I've got two options to embed. I can use an iframe embed, which is very easy, or the embedding SDK if I want to configure it, get a little more configuration options. So pretty easy way to embed. And then it's also pretty easy to edit. So I'm just going to edit this donut chart because Ken apparently likes eating donuts. And we can change the chart type.
Donuts are good.
They are. It's easy to change the chart type. I can drag and drop fields in here if I want to, like if I want to filter out some of the data by date, I can just drag it in here. And let's say we just want to get the data from the last year. I can do that. Click of a button, and in just a moment, we've got updated data. Pretty easy. Very powerful, a lot easier than programming these all yourself.
It's hard to gauge my excitement.
It is. It is indeed. Thank you, Ken. Thank you for giving me something to work off of here. Okay. All right, one more piece of the demo for you. Let's talk about Atlas Data Lake and Online Archive. So Ken talked about Atlas Data Lake earlier. So Online Archive is a really handy feature that you can leverage as part of Atlas Data Lake. So I'm going to open up, this is a different cluster than what we were in before, a different data set. And this is for Ocean Watch. So let's see, I wrote some notes down so I could get it right. So the sample data we have here is from an organization called Saildrone, whose fleet of drones are equipped with atmospheric and oceanographic sensors. So Saildrone's mission is to create the highest resolution ocean data set in the world and use it to make global processes such as weather forecasting, carbon cycling, global fishing, and climate change more predictable, visible, and actionable. So we've actually got a ton of data here. We have data going all the way back to January of 2019. So we know this older data is not going to change, right? It's set in stone. It's not changing. So we can archive it. And when we archive data in the data lake, we're going to pay less for it. So what I have done is, let's see, where's the online archive button? There it is. It's over to the right because I'm zoomed in. I've set up online archive, and this took just a few clicks. And what I've done is set it up so that anything that's older than 365 days, so anything older than a year old, is going to automatically be archived for me.
So you're going to sail that over to the data lake?
Yes, I'm going to sail it over.
Okay.
So, okay. Yes, so it's going to sail on over, right? I don't have to come in and manually adjust anything. It's just going to happen for me, which is really nice. And I think they just added this year, there are different ways to configure the archive. So it doesn't necessarily have to be time-based. You can set a field if you want, or you can configure it however you want to automatically set up that moving to the online archive. So I just want to show you how this works, because you can still query the data even if it's in the online archive. So when you choose to connect to your cluster, I'm going to choose to connect with a Mongo shell. And you can see here, I've got 3 different options for connecting. So I can connect to my cluster, that's my hot data, my latest data, my online archive, that's data that's a year old, or I can connect to my cluster and my online archive together if I want to search all the data together. So just to save a little time, I went ahead and set up connections to all 3 of these in my terminal. Let me drag that over. So I kept them in the same order that they were on the screen. So this first one is just the online archive. No, the first one is the active data. The second one is the online archive. And the third one is them combined together. So I went ahead and connected and switched to the database that I need. So first thing, let's just check and see how many documents are in each location. So I'm going to say db.saildrone.find. I'm going to find everything in there, and I'm going to count. So I just want to know how many documents are in this, this collection. So we can see we've got almost 46,000. in my active cluster. I'm going to do the same thing here. And this is querying my online archive. This is my older data. So there's a lot more data here, and it's going to the online archive. It's a little slower. Let's see how many documents we'll have here. Oh, I'm scrolling accidentally. Maybe.
It doesn't like you today.
No, it's rude.
There we go.
Okay, there we go. So 443,000-ish records. Do the same thing over here, combined. So Ken, how many documents should we get over here? We've got
about 489. Yeah, about 489.
489. That was fast math. Were you prepared for my question?
Sometimes.
Sometimes. All right, you can tell. Oh, there we go. 489. You were right on it. So there. Okay, so now you can see we're getting data from both the active cluster as well as the online archive. So I'm going to do one more query just to show you how this works together. And I'm going to write an aggregation pipeline. I'm not going to get into how this query itself is working, but let's talk about, this is the query that I just pasted in. Let's talk about the results down here that are not highlighted. What it's doing is grouping the documents by year and month, telling me how many documents are in that grouping, and then the average water temperature. So we can see we've got stats from March 2020 forward. Well, that's poignant. Okay, life changed a lot then, didn't it? Who doesn't want to remember March 2020? Okay, so now we're going to do the same thing in our online archive, and hopefully we're going to get data that is older than March 2020 if everything goes well. Can I give you permission to tell a bad joke while we're waiting for this?
I don't have any bad jokes.
Okay, that's a lie. All right, but yeah, we can see we've got data from January 2019 up through March 2020. All right, I'm going to run one more query just so we can see together, and hopefully we're going to get that full data set that'll combine what we just saw from the last two queries.
But it's a live demo, so one never really knows, right?
One never knows. Yeah, Ken, you always have a bad joke. I can't believe that you're telling me you don't have one.
Maybe that was the joke, that I don't have any jokes.
Hey, it worked, right? So we've got January 2019 all the way through June 2020. So just to emphasize what's happening here is, we're able to easily query our data, whether it's in our active, our hot cluster, or our online archive where we're paying less for that data. So we've got a lot of power here in how you want to query your data and how you want to store it. All right, that's the end of the demo. Back to the slides.
Back to the slides.
Back to the slides. Here we go. So OFish has a lot more features that I don't have time to show you today. It has both an iOS and an Android application that both have offline sync capability. It's very cool. So if you want to watch the full demo and see all of the features, check out the MongoDB.live keynote, which is available at the URL on the screen. And I don't have that ready to copy and paste, but I'm sure we can get it. And then also, OFish is completely open source. So sometimes people ask me, like, what's a good project that I can go in and try out MongoDB? This is a great one. It's a really nice community. Shiri, who is answering questions here, has been very involved in this project, and it's a lot of fun. So if you want to try out the app for yourself, read the docs, or contribute to the code base, visit wildaid.github.io.
Very nice. Great demo.
All right. Thank you. Take us home, Ken.
All right. So tips and tricks here. Let's, I don't know, kind of zip through some of these tips and tricks just to, we all have things that as we've gone on our journeys and whatever technology that we've focused on, that we've discovered folks don't focus on very much or enough, or sometimes at all, that really make a big difference when you're coming to a new technology. So the first one is using indexes. We get a lot of customers and users out there that either don't use indexes or don't use them correctly and properly. And so my first tip is to make sure that you have proper indexes in place on your collection. As Lauren mentioned earlier, indexes are very important for read performance, but we don't want to create an index on everything, especially if your database has a lot of write operations occurring. For those that maybe haven't explored MongoDB for a while, in version 2.0, or 4.2, not 2.0, 4.2, we introduced wildcard indexes, which allow support for queries against unknown or arbitrary fields, which is pretty cool. And MongoDB Atlas, here's another great feature of MongoDB Atlas. As your data gets queried a lot inside MongoDB Atlas, Atlas itself can actually recommend some indexes for your collection based on the queries that your data is experiencing. And this can really greatly increase your performance. So again, indexes support the efficient execution of queries in MongoDB, but they do come with overhead, right? You don't want to index everything because indexes are a data structure in themselves. So one question, and I'm sure Lauren, you've seen this question before. If indexes improve the speed of queries, why not just index every field?
Don't do it.
But why not? I mean, we want things to be fast and fast reads. Well, they come at a cost. So an index is a data structure, and they're not free. So every time you do a write operation, that entire data structure gets updated. So think of indexes as like the index in the back of a textbook, right? And if you're constantly updating the textbook, that indexing structure in the back has to be updated as well. So while they greatly enhance the query performance, they also can take a hit with the write performance. So there's a balance that needs to be struck there. And if an appropriate index exists for the query, MongoDB can use that to limit the number of documents it must inspect. We support a number of different index types, such as single field, compound, multi-key, geospatial, which I think we've kind of touched on geospatial a lot today, which is just a spectacular feature. Text indexes.
Spectacular.
It is. Hashed, wildcard, which again, 4.2, not 2.0. 4.2 was when wildcard came out. My next tip is about schema design patterns. Lauren has some experience with this with her anti-patterns blog, but really look at how your data is modeled. MongoDB supports this flexible document structure, but that really doesn't and shouldn't mean that anything goes. There's definitely some considerations to think about when it comes to schema design. In fact, many of the performance issues that we see overall from customers and out in the field are a result of schema design decisions that were made. We have come up with several different schema design models that help in this fashion. And, thanks for pointing that out. There's a good schema design pattern blog series that was written a couple years ago by myself and Daniel Kupal. So let's take just a real quick look at an example of one of the patterns here. So why do we create models in general and kind of create patterns, right? In a perfect world, we don't really need to have models and create patterns and whatnot. If everything on Earth was super fast and resources were abundant, you wouldn't really need to worry about how and where data is stored. Thanks, Artem. Thanks for joining. So for example, Lauren, when you get up in the morning, do you think about how you're going to need to breathe air?
Not usually.
Not usually. If you were the astronaut who isn't streaming because you can't, or you're not doing Twitch because people can't hear you stream in space. But if you're an astronaut, how big of a consideration would air be, right? Like,
I would hope somebody would be thinking about that for me.
Yeah, right. So if we had unlimited resources, we wouldn't have to think about this. But in reality, things like hardware considerations, server considerations, data size, all those things are in reality a factor. So that's why we create patterns. We've separated out our patterns into kind of 3 different categories, which are on the next slide.
That's me. Okay, yes.
It's all good. So we have 3 different kind of buckets of schema design patterns. There's representation patterns, frequency of access, and grouping. And so we'll talk about one of my favorite ones, schema versioning, which I think is really helpful when you're doing.
Oh, we lost Ken again. He was busy saying that he had a favorite schema design pattern, which, Ken, we lost you. And
so that's
you were telling us that you had a favorite schema design pattern, and I think I'm gonna have to make fun of you for that, actually.
It's schema versioning.
It is. Okay. It's normal to have a favorite schema design pattern. People in the chat, do you have a favorite schema design pattern? Maybe it's normal. What's your favorite schema design pattern?
Because everybody should have a favorite.
Everybody should have a favorite.
Yeah. So schema design versioning pattern of schema versioning. If you add a field to track the schema version number in each document, it will allow you then to progress your schema design and your document structure for that versioning. The first version doesn't necessarily have to have that version number, right? So if you think about maybe even the data from Saildrone from 2019, that data isn't ever going to change. So you don't need to tag that with a schema version number. As we progress in time, doggos went bonkers again. As you progress in time, maybe you're changing how that structure looks, and then you can allow your application to handle that. There's really a lot more to data modeling with MongoDB, and we have on MongoDB University. There's a course M320. It's on data modeling. Highly recommend that you take a look at that, in addition to the schema design pattern blog series, and additionally the anti-pattern blog series that Lauren wrote that says not just here's what you should do. Yes, the Mountain Dew pattern. There you go. But her anti-patterns talk about kind of what not to do. Really, I mean, there's a lot of that out there as well. What's my next tip, Lauren?
I don't know. Oh, it's a bad joke.
No. Reduce your aggravations with the aggregation framework. So I guess that's my only joke. So really,
that's your only joke
for this, I guess.
Okay.
I wouldn't want to aggravate you.
There it is.
Sorry. You really want to use it whenever possible. The operations with the aggregation framework are done on the server side, and the orders of stages does matter. So let's take a real quick look at a sample aggregation pipeline. It's really similar in concept to a funnel. A bunch of documents start at the top of the funnel, or in this example, the left side here. A series of operations are performed on the documents, and the results come out at the end. In this particular example, we have a bunch of different documents on the left. We do a match with that $match for all documents that have red diamonds, which then reduces our data set. We do a project stage, which allows us to reshape our documents. In this example, we are reshaping the snowflake and triangle to be a square, regardless of the color of those shapes. Then we do a lookup stage, which is a join operation, so we're looking at from a different collection. And finally, in this example, we did a group stage and group items based on the color of the square. Very powerful framework for massaging and interpreting your data. So in concept, it's very similar to a Unix pipeline, right? We're getting the running processes here in this example. We're searching for the MongoDB process, and we're printing out the first line of the data. And I thought animation was automated, but maybe it's not. Oh, I guess it is. Yay. In the MongoDB aggregation framework and its pipeline, instead of Unix commands, it's stages. And what's going through those stages are documents. This is a very brief intro to the aggregation framework. I'd highly recommend looking at some of the resources MongoDB has to learn more about it, including courses on MongoDB University. Our documentation is pretty good on aggregation framework. I'm sure there's got to be something on the Dev Hub, developer.mongodb.com about aggregation.
There sure is, Ken. All of our quick starts cover the aggregation pipeline. So once again, I'll mention my Node.js quick start, just refreshed this week, covers chain stream and aggregation pipeline. And CRUD, which Ken talked about. Covers everything, so check it out.
And what does CRUD stand for? I mean...
Create, read, update, delete.
Oh, she even does it to a little tune. That's awesome.
I'm working with video people this week on recording videos about CRUD. And they were like, I was like, so we'll have the CRUD video. And he's like, wait, I just want to make sure. Are we calling this the CRUD video? And I was like, yeah, it's a thing. I'm not making it up. It's a real thing. But yes, CRUD.
All right. So in summary on my tips and tricks, use indexes. They support a very efficient query executions. Don't just lift and shift your schema design from relational to MongoDB. There's a lot more to think about schema design than just doing a lift and shift. And if you look through the courses that we offer, the blog post, you're going to quickly realize why lifting and shifting is not great for performance in MongoDB. And finally, my last tip is to use the aggregation framework whenever possible, as it's a tremendous feature for data retrieval and analysis.
Oh my goodness, we have made it
Woohoo!
through this presentation. Do you want to summarize, Ken?
So Lauren kicked us off by discussing terms and concepts. She walked us through how to model data in a relational database versus MongoDB. She then explained how to map terms from relational to MongoDB. And we really want you to remember those first three, right? Rows map to documents, columns map to fields, and tables map to collections. Yes,
this recording will be saved. It will be up on, I believe it will be on YouTube shortly after this. So yes, you can go back and watch it. So thank you for hanging with us. Oh,
absolutely.
Available immediately.
Ooh,
all right, back to you, Ken.
Technology is amazing until it isn't.
Yeah.
So in summary, terms and concepts. We saw that's last slide. Remember that what we talked about there, the data platform, three big things: storing data, accessing the data, processing the data. So storing the data with self-managed Atlas and Atlas Data Lake, accessing the data with workload isolation and change streams are examples of that, and processing the data with things like Compass, Charts, Business Intelligence Connector. Of course, you can access the data with driver of your choice and process the data in a whole variety of ways. And then tips and tricks, three big things to remember: indexing, schema design, and aggregation framework.
All right. I think we have made it.
Holy moly.
So, all right. So thank you everybody for hanging with us. This stream went way longer than we expected. I guess Ken and I are chatty. But thank you all so much. And joke. Well, I guess they were jokes. Quality. But yeah, thanks so much for watching. And don't forget to like, share, follow, you know the drill, all those things. I'm going to drop my social one more time in the chat. You can find me on social, unlike Ken. Yeah. And we would love to hang out and chat with you in the MongoDB community. So if you have any more questions, we have people from MongoDB, employees, as well as developers all throughout our developer community on there every day answering questions. And we would love to see you there. The URL is community.mongodb.com. It's our forums. Come ask all of our questions. Oh, thank you. We're awesome. We're amazing. Oh, I love this.
Thank you all for joining. It was a lot of fun.
It was a lot of fun. Do you have anything else? We plugged a lot of stuff today, so I just
and you
go read all the
Mountain Dew.
things. I plug Mountain Dew. Please sponsor me. I will drink your Mountain Dew. All right, I think that's it. We're done plugging things.
Great job, Lauren. Always a pleasure to hang out with you from 3,000 miles away. Yeah, hit the like button, subscribe. I feel like do all the things.
Do all the things. 3,000 miles. I feel like that's close enough. We're good. 3,000 miles.
Yeah, that's about an appropriate distance. Yeah,
I think so. All right. We will see you all on the stream again at some point. We'll be back unless we're banned due to Ken's bad jokes. All right, that's it. Bye.
All right.
Bye, everybody.
Bye, everyone.